new students, and also as a good example, what do you guys remember from the last lesson? I'd love some students to put their hands up and tell me what do they remember from what we did in the last lesson? Who remembers something from the last lesson? I know we spoke a little bit about y-intercepts, and Kat has said we also found x-intercepts. Yep. We spoke about quadratic functions. Yes. And we spoke about what they kind of looked like a little bit. We also spoke about straight lines. Oh, we spoke about shifting parabolas. That's right. And Bongani, what do you remember? Can you hear me, Bongani? Maybe we've lost you for a second there. Is the audio, I think might have a bit of an, or maybe my internet's being funny. Okay, let's go to Fatejo. Fatejo, what do you remember?
Hi, sir.
Hey. Can you hear
Sir,
me?
can you hear me?
Loud and clear.
So we spoke about f of x and g of x.
F of x and g of x, so the notation,
Yes.
f of x and g of x. Yep, perfect. And then we spoke about shifting functions. Do you remember me doing things like what happens if the graph of x squared becomes x plus 2 squared? So we spoke a little bit about shifting. This shifts it horizontally by 2 units to the left. We also spoke about what happens if I do that, and that shifts the graph up or down. So this goes up or down. That's whereas this one over here, that goes left and right. Okay. Now, there is actually another one that we could vary. We could change the number in front of the x squared. Now, I didn't talk about this last time, but what do you think happens if you put a bigger number in front of the x squared? Anybody know what happens when we do that? Like if we think about the basic y equals x squared graph, what happens if I put a 2 in front? Aha, it doesn't become wider. Actually, the 2 makes it steeper. So it actually makes it narrower. It goes up faster. So it doesn't move up so much as it just basically gets steeper or narrower is another way of thinking about it. So this number in front would look like that. However, what would happen if this number was minus 2x squared? So now the blue one is the 2x squared. The minus 2x squared actually, it's a sad parabola, yes. So in fact, it should be narrow because it's got the 2. So it's going to look, it's almost like the blue one got flipped over the x-axis is what that would do. Okay, so the things that you need to know about going from a basic parabola, the simplest parabola in the world is y equals x squared. Now, if you add a number on at the end, it can go up or down. If you add a number to the x, you can go left or right. And if you put the number in front, that makes it steeper. And so when we talk about parabolas, what we're going to move on to today is the standard form of a parabola and a turning point form of a parabola. So this is called the standard form of a parabola. And this is called the turning point form of a parabola. And these two can be equivalent, but sometimes they give it to you in this form, and sometimes they give it to you in this form. And I just want to highlight the fact that this A over here is the same A that's here. So it affects the steepness. This bit over here affects the horizontal shift, and this one over here affects the vertical shift. Okay. What else do I want to show you? Let me just show you. Let's make up a parabola and just see what it would look like if I just shifted it. So let's make A1, and then I'm going to make this -2 squared, and then I'm going to make this, let me make it -1. Now we're going to start drawing graphs shortly, but I just want to show you something about how I can draw this graph. So this graph started out in life as y equals x squared, and then this happens. What does this do, this x minus 2? I think it takes the graph that used to be anchored here and moves it 2 units across. So it's 2 units to the right, and that takes care of this. But then what does the -1 do? I think it moves that down by 1. So the turning point of this new graph is no longer going to be at 0, 0. It's now moved to the point 2, 1. Now, the other thing is, because there's a positive number in front here, this is going to be a happy graph. And so this graph is probably going to look something like that, because all that's happened is the graph has shifted across by 2 and down by 1, and that's because of the stuff up here. Now, I don't know, that might be a bit complicated for early in the lesson, but give me a thumbs up if you're following that little thing I did, and give me a thumbs down if you have no clue what I'm talking about. Now, what is a bit sneaky is that x minus 2 doesn't go to the left, it goes to the right. So the horizontal shift will always go the opposite way, whereas the vertical one goes down. Now, I want to show you something else. What if I want to convert this turning point form into standard form? Do you know what I can do? I can write it out like this. And then what I can do is the 1 doesn't do anything. So I can go x times x is x squared minus 2x minus 2x plus 4 minus 1. And then I can write it as x squared minus 4x plus 3. So this graph that I made up, which was in turning point form, has an equivalent, is the same graph written in standard form like this. And I want to ask, I'm going to get to the question in a moment, but let me ask another question. Give me a thumbs up if you understand how these two are connected. Give me a thumbs down if you have no idea how the one is connected to the other one. Okay, and then I'm going to go to Zidaya or Zidasai. What is your question?
So the one in the blue on the side, is that a trinomial?
It is a trinomial, yes. And
So then
it's written in what we call standard form, but it's exactly the same graph as 1 times x minus 2 squared minus 1. They are the same thing, they're just written in a slightly different way.
Okay, and then I have one more question. You wrote
Okay.
y equals 1 times, and then in brackets, x minus 2 squared.
Yes.
So then what if there's no a value?
Aha. Okay, if there was no a value, like a 0, it wouldn't be a parabola anymore. What's more common is for it to like be a -2 or a 3, and then you would have to then multiply it out. But this number tells you whether or not the graph is happy or sad. So that's why I knew this was going to be a happy graph, even though I didn't know exactly what was going on yet. But if I look at this, I know that the y-intercept would be 3, and that's quite easy to see from the standard form. Does that kind of make sense?
Yes. So if there's no a value, you can't just put it as 1.
No, no. I made this up and I kept it at 1 because I just wanted it to be easier for now. All right.
Thank you.
So this is just the warm-up. Let's get going with the actual content. Although it's quite a long warm-up, it's worth doing it. So let's talk about if I wanted to draw this parabola. I'm going to show you the process I use and notice how it's given in standard form at the moment. Okay, so step 1. Is this a happy or sad parabola? Is it concave up or concave down is another way of saying it. And the number in front of the x squared tells me what's going on. Okay, it's sad or concave down. So you can go, that is the shape of the graph I'm drawing. Okay, step 2. What is my y-intercept? Using what you've learned about y-intercepts before. It has to be 20. Awesome. Step 2 is I want to find my x-intercept. So I make that equal to 0. And I want you guys to find me the x-intercepts of this parabola. So over to you. You solve it whatever way you can. For those who are a little rusty, the quadratic formula can be quite helpful. And that is that one. What are we getting for our x-intercepts? I'll give you some more time for that. Okay, so Andila has an idea. So Busisiwe, what we're doing is I'm giving you a 5-step plan for drawing a parabola. So this is still the early stages. And what I've said is I want you to find the x-intercept in step 3. And so to find the x-intercept, you make y0, or this g of x0. And now we have to solve this quadratic equation. And that's what students are busy doing. And I'm waiting to see what answers we get. So I subbed into the quadratic formula here, and what are we getting? So we get, that's going to be plus 160, and that's 64. So that's 224. I get a messy answer. I don't get a neat 5 or minus 1. I get like a messy decimal answer. Because I get delta as 224. And I did that in my head, 64 for the 8 squared, and then 160. So what are my 2 x-intercepts going to be? I see the answers coming through. Yeah, so 5.74 is the one answer. Yeah. And then minus 1.74 is the other answer. Okay, now in order to draw a parabola, you need one more thing. So you need the y-intercept, you need the x-intercept, and you also need something called the turning point. But the turning point is made up of 2 things. The axis of symmetry coordinate. So if I was drawing a parabola, let's say, I'll do a little sketch here. Say my parabola looks like that. A parabola can be cut exactly in half along the axis of symmetry. And to figure out what the axis of symmetry is, we use the formula minus b over 2a. So I want you to go back to the original and tell me what the axis of symmetry is if you use the formula b over 2a. I want you to work that out. Maybe not a bad idea to even just say as. What's the axis of symmetry going to be? Yeah, so Linda, we're going to get to the turning point now. That's step 5, and it includes this thing called the axis of symmetry. So I'll explain it to you now. So minus 8 over minus b over 2 times minus 2, which gives me minus 8 over minus 4, which is 2. Okay, so what you found now is x is 2 is where the axis of symmetry is happening. Now, what I need to find is I need to find the y coordinate that goes with the x is 2 to get my turning point. And what you do for this is you sub 2 back into the original equation. So you want to get how do you do that? Well, it's going to be wherever there's an x, leave a space, and then put a 2 in there. And what are you going to get if you do that? We can unmute Owetu. Owetu, what is your question? Owetu, do you have a question? Maybe. I think we're struggling to unmute Owetu. Maybe we can go to Tato. Tato, what's your question?
Afternoon, sir.
Hey, how can I help?
So as today being taught, there's this other method at step 4. Can you still use same by x1 plus x2 over 2?
Yes,
because
you can.
taught today.
Yeah,
Okay,
you can.
sir.
You can do that. That will also work because the axis of symmetry will always be halfway between the two roots. So
Okay, sir.
both methods will work, yeah. So for step 5, when you put this in, you should get minus 8 plus 16, which is 8, so that's 28. So my turning point is 228. Now, those are the 5 bits of information I need to draw my graph. Now, once you've done this, actually the hard work is over. But I'm going to show you how you would draw the graph. And then after the break, you guys are going to start drawing these things for me. So what I do is I start by looking at my axis of symmetry, which is 2. And I go, okay, let's say 1, 2. And I make an axis of symmetry because my graph must be symmetrical across this line. So that's then what I do is I say, look, I need to go through a whole bunch of other points. I need to go through, okay, maybe I haven't got my scale perfectly here, so I'm going to be a bit out of thing, but here's y is 20. So this is this one. And then I'm also going to need to do minus 1.74. So let's say that's the 1x intercept, and then 5.74, which would be on this side. And then my turning point is at 28, so even above that. So my graph, my unhappy graph, has to go through these points. And so what I'm going to do then is I draw it like that. And I draw it like that. So I go through those dots. Now I'm not done because I still need to label these dots, but at least it's easier if they've already been in there, it's easier to go through them. So what are my labels? They're going to be minus 1.74, 5.74. This one was 20. And this one up here was 228, which is the turning point. And the final label was the graph G. So really the hard work is being done in the 5 steps. And then you just have to put your smiley or unsmiley face through the dots. Okay, Joy is saying, please repeat step 4. So step 4 is a formula for finding the axis of symmetry. And if your graph is in standard form, you go minus b over 2a. And so since b was 8, I get minus 8 over 2 times minus 2. So that's a formula. However, it's also not wrong to take the average between the two roots. So if you go 5.74 plus minus 1.74 and divide it by 2, you'll also get the right answer. That's not wrong. Okay, I saw some questions there. Whose hands were up? So would the y value of the turning point be the range of the graph? I'll talk to you, Linda, about range in the next thing. But yes, if you look at this graph, the range, the highest value this graph gets to is 28. So the range of this parabola would just be y is less than or equal to 28. So we're gonna take a break in a moment, but after the break, we're gonna just draw these graphs. We're probably gonna draw them 3 or 4 different graphs in the second half an hour. That's 5. So for step 4, you need to use the minus b over 2a idea, or you need to add the two roots together and divide by 2. So I think you might have made a mistake there. Is this formula only applicable to trinomials? Because my teacher gave a different formula. I tell you what, let's carry on after the break. And when we draw more of these, we'll get to compare your formulas that some of your teachers have used. And I will try my best to try and explain how they're equivalent, if they are equivalent. But we've done quite a lot of work and our brains are getting tired. So it's time to stand up and stretch out your legs and let me do the same. And then I will come to questions after the break, I promise. Okay, so what I want to suggest we do is, to start our little brain break, is you just find something that relaxes you. So I like just pretending I'm just spinning around, and I like that feeling of freedom. I'm just letting my body slowly rotate further and further around as I relax more. If this doesn't relax you, do something that does. But I like it because I can feel as I relax, I go further. There we go. Okay. And then shake out your arms. So like get some blood flow in your arms. There we go. Oh, that feels fantastic. Guys, you're missing out if you're not. Shake out your legs. Oh, I should be doing this all day. Okay. And then let's roll the shoulders. Oh, feels so good. Roll forward. Yeah, maybe stretch your neck a little bit. Yo, I can feel my neck. Okay. And then give yourself one more last shake. So once you've relaxed your body a little bit, we want to get your heart rate up. And so all we're going to do is we're going to do some jumping jacks just to get blood flowing through your body and hopefully some oxygen too. So make sure the room is clear, that you're not going to whack anyone or anyone's light. And we'll start in 3, 2, 1, 2, 3. Ooh. And go. Halfway. Ooh. And 3, 2, and 1. And sit down. Ooh. And let's
I'm
have
definitely unfit.
the jumping jacks are no joke. So I've been doing my local park run, so I think I'm getting fitter. So I have to watch out. Maybe I'm going to push
Oh, nice.
But okay, so 2 choices for your brain break. You can either do the puppy question or you can do the math 24. Tell me which one you think is which one you can answer. Ooh. Yeah, I do feel my heart rate. being up, but that's the point. So the goal is to find out the bottom line here, or to tell me how you make 24 using these four numbers. Oh, sure, yeah. I definitely noticed that. So that must be 7. That seems fairly clear. Now, what else? Sandile has said 19. I don't know what the answer is yet. So 16, 22, 4. Well, I think the yellow dog is 3. So, and then 7 plus 3. So this one must be 6. So, and that must be 6. So we have 7 plus 6 minus 3 plus 6. So that's going to be 10 plus 6. The final answer is 16.
Nicely done, guys.
Okay, so watch out for the 22s because that's a plus 6, not a, yeah, at the end there. And anybody got the maths 24 question? Anyone managed to get that right? Can you make 24 using the blue card? So iPhone 7 plus 5. 7 plus 5 times 4 minus 2. Does that work? So there's a 4 and there's a 2, 7. And so that's 12 times 2, which is 24. Yes. I agree, iPhone. You have cracked the case. Well done. Okay, so back to the main focus for today. I hope that you enjoyed our little dance down another thing. I want you to draw the graph for me of this one. I'm going to draw it. I'm going to write it out a bit clearer. So y equals minus x squared plus 4x minus 3. I want you to do the 5 steps, and then I want you to try and draw the graph for me. And I want to see how much you can remember from before the break. And I will leave the other question up on the screen so you can kind of see it. But remember that we're now focusing on doing 5 steps for this one. Okay, off we go. Step number 5. Okay, Zizzy. So step number 5 is just finding the turning point. And so in step number 5 here, I went minus b over 2a when referring to the original equation up here. And I got the answer 4. Sorry, I got the answer 2 for the axis of symmetry. And then I took that 2 and I put it back into the original, and I got the value of 28. And so that's why my turning point on my graph over here is the point 228. That's where the graph turns. But you'll see me do it in this next one again. Oh, it's a bit small, but. So I think this is an unhappy graph. And I think it's pretty obvious that the y-intercept is minus 3. Now comes the more exciting bits. Pleasure, Zazie. Pleasure. We have to solve this. And you could factorize it, or you can use the formula. Doesn't really matter. So what are my x's going to be? It feels parallel. Do we agree? Who else gets x values of 1 and 3? Yeah, Linda and Ongani agree. Anyone else agree? So I think x is 1 or x is 3 is the x-intercept. Yeah, what's the question from Awande? What is your question? Can you hear me, Awande? Maybe there's a bit of a blockage there, I don't know. Okay, well, while we were there, step 4 was to find the axis of symmetry. So the formula I gave you was minus b over 2a if it's in standard form. So what's my axis of symmetry going to be? And then what's my turning point, my full turning point going to be? So minus 4 over 2 times the minus 1. Oh, it's 2 again. But that's just a coincidence, eh? There's no guarantees. But now this 2 has to go back into the original thing in order to give us that value. So we get minus, so minus something squared plus 4 times something minus 3, but that something is a 2. And what do we get? We seem to get 1. So my turning point is 2, 1. Okay, so the hard work is now done. The only thing we have to do still is draw this graph. So I want to give you some time to put all this information onto a Cartesian plane, and then I will come along and show you how I did it. So Kayleen, I think maybe you put the wrong values into the formula. So there might have just been a typo along the way. So inside your delta value should have been 4. So inside your square root, you should have had 4. Just check that. Bonke Kosi, what is your question?
Sir, my question is that at step 3, do we change the a that is negative and make it positive when we do our
quadratic? You can.
Yes.
It won't really matter as long as you're consistent. So if you do bring it across, then your new equation is going to be x squared minus 4x plus 3 equals 0. So you can do that and you'll get the same answer. So it doesn't matter as long as you're consistent.
Okay, thank you.
Pleasure. Okay, now what was my first step? I always seem to go for the axis of symmetry. So I like it because it divides my graph into 2 equal halves. And then I put dots for the points I needed to go through. So what were the points? And I know this is going to be an unhappy graph anyway, or a concave down graph, if you want to use the technical. Aha. Okay, so both are positive, but your one x-intercept is here at 1. The other one is at 3, which is here. Now, where was my y-intercept? It was at minus 3. So let's say down here. So there are my 3 dots, but my turning point was at, and remember the turning point is always on this dotted line. The turning point is just going to be here because it has to be on this axis of symmetry. That's why I like drawing the axis of symmetry first, because it gives me a guiding line to get my turning point. So now I've got 4 points. and it's unhappy. So I can kind of see that I'm in the right. Sorry, this is not my best graph ever, but you can see that that's the shape. And what do I still need to do to get full marks still? So I have to label, yeah. So this will be -3. That's 1. That's 3. And then this is the point 2, 1. And the graph is just the graph. It would be nice if they used the label like G, but they didn't. So the question in the chat is, so can we start with the axis of symmetry and end with solving the x-intercepts? You could see Bachle. I stick to this because I think it does. There's nothing wrong with doing it in a different order as long as you do all 5 steps, to be honest. How many points should your graph have? So normally your graph will have at least 3 points, but normally 4 because it's the 2 x-intercepts, a y-intercept, and a turning point. However, there are some parabolas which don't have any x-intercepts, like if the graph was like here. So it's hard to give a definite rule. Please explain the formula used on the left of the graph. What do you mean by that? Okay, I tell you what, while I want to ask, while I'm going to discuss this graph, because I can see there's lots of questions, I want you guys to try and draw me this graph. But notice how this graph is written not in standard form, but in turning point form. So I want you to think about how can you adapt your 5-step program so that, or the 5-step process so that it helps. Okay, but I'm going to let you decide first while I take questions on the previous example. So it's 4 marks. Yeah, so Viteko, you get quite used to, you get a lot better at this. So it becomes easy eventually, I promise. So are the dotted lines necessary? I think so, Paul. It gives your graph. It's also easier to draw the graph when you know it must be symmetrical across that dotted line. So yes. So I was taught to make the equation to something x minus 2x plus 2. Okay, Michaela, that's you talking about, I think, transforming it from standard form into turning point form. Now, at the moment, this is in turning point form. Now, you can still, there's 2 choices. The one is you can break this apart and turn it back into standard form, or you can work with this, you can work with it like it is. So for example, since there's a 1 in front here, I know, even without breaking it apart, I know this is going to be a happy graph. Okay, so I could start by just using straight from that. But if you would like, and I think a couple of you will like this, you can break it apart by just changing it by doing this. I'll do both methods to show you guys. So if you like, you can rewrite this minus 8x, and then this is going to be plus 15. So this would be the standard form. This would be the turning point form. Now, there are some advantages to the turning point form, but either way, you need to get me those 5 steps. So use whatever you want to get those 5 steps, and then I will show you the 2 ways you could have done it. Okay, what is the first step? And then to draw it. So is the turning point basically the new origin? Linda, sort of like so if you, that's the turning point moves away from the origin to, the turning point on a simple parabola is at the origin. On a parabola that's been shifted, the turning point is somewhere else. Yeah. So if you were using, I'll show you both approaches. So in this one, you can see it's happy. It's a bit harder to find the y-intercept when you leave it like this, but you know that you make x naught. So if you make x naught, minus 4 squared is 16, minus 1 is 15. If you have it in standard form, you know that the y-intercept is 15. So at least both ways give you the same thing. Now the next question is, what's the x-intercept for this parabola? And there's two ways you can do it. You can either do it like that, or you could leave it in turning point form and solve that equation. Or if you were using this method, then you would get well, the good news is both methods give us the same answer. Now, what's my turning point going to be? Well, in this one, it's going to be minus b over 2a. Now, in this one, actually, it's quite simple, but I'll talk about that in a bit. What is my turning point going to be? So minus 8 over 2 times 1, which gives me 4. And then to find the turning point, 4 goes with something. If I sub it back into the original equation, it seems like I'm getting minus 1. Cats, I'll get to you in a moment. So your turning point, now, if you used standard form, you do the normal thing and you get it. Now, I've left in the turning point form, notice how I've left 4 and 5 empty. Now, the thing about the turning point form is it gives you the turning point. Now, all you need to do to get the turning point, the axis of symmetry is going to be x is 4. And it's just going to be minus whatever is here. Because remember, this x minus 4, it just shifted the graph 4 units to the right. So when it's a turning point form already, your axis of symmetry is just the opposite of whatever's in the thing. So if there's a plus there, it's going to be minus. If there's a minus there, it's going to be plus. And then the other thing is basically this is just going to be 4 minus 1. And you can just read it off straight from the graph. Sometimes in textbooks, they say the turning point is minus PQ. So whatever the number is here, it's the negative of that. And then whatever this was is the Q. So you can see that both methods will get us to 5 things that we need. Now, for the last step, I want you to draw this graph for me. So you can use whatever, you've got your 5 steps. I want you to draw the graph for me. It's been a good session today. We've done a lot. So I've got 4 dots. So for Tekel, you have to have, it's a sketch graph, so it doesn't need to be perfect, but it has to be roughly in proportion. So for example, this y-intercept has to be bigger than the x because the y-intercept is the number 15. So it clearly should be quite a bit bigger than this, but does it have to be exact? No, but it should also be symmetrical across the dotted line. So what I like to do when I draw it is I just draw one half first, and then I draw the second half like that. And if you draw them in 2 halves, it automatically looks a bit neater. That's my little teacher trick for you. If you draw it in 2 halves, then automatically it comes out more symmetrical. So that's 4 minus 1. That's 3. That's 5. That's 15. And then we have to label what was the function called. It was called the function f. So we label it like that, and it's f. Okay. So even if they give it to you in turning point form, what you can do, you have 2 options. The one is to get the turning point straight from the turning point form. That makes sense, right? It's in turning point form. Or you can break it back into standard form and then do it like this. Both will work. Should we squeeze in one more? Have you guys got enough energy to do one more? Can we do it? Go team. Okay. One for the road. Okay. So let us do, you are going to do this graph. I want you to do the 5-step process for this graph, and then we're going to draw it, and then that is it for today. We sketched 4 complete parabolas, and we've spoken about the shifts and things like that. Where did we get the -1 from the turning point, Obile? Obile, what I did was, in the previous question, I took the value of 4 and I put it back into the original. So the original in standard form was this. And so I just did it, I did that. Or if I was looking at the turning point form, then the -1 was just the bit in the end there. If you look at my turning point form, there's this -1, which is basically the y coordinate of the turning point. Okay, so when we label the intercepts, don't we have to write them in coordinate form? And Paul, that's a good question. It depends what the question says. If it says label them in full coordinate form, yes, then you would write it 3, 0 and 5, 0. If it doesn't say that, you are allowed to just write it like that. It just depends on the question. So do what the question says. I sometimes don't, just because of time, and obviously I have the choice. Transforming the standard form to the turning form in completing the square. Okay, Linda, I'm going to talk to you about going between the standard form and the turning point form in the next lesson, but I think completing the square is the harder way to do it. You do sometimes do that, but a lot of the time you can work out the turning point like we do in the standard form way, and then just work backwards. So once I know this is a 4, I know the graph it came from was x plus 4, and I know it must have a -1 here. So I think completing the square, whilst it's useful in some ways, it's a bit hard to carry out as your default operation. Okay, we have a choice. For those who want to break this into standard form, you would have to multiply out. For those who are happy to stay in turning point form, you can start straight away and say it's happy. So you need to make your choice, which one you think works for you. It does take a little bit more work at the beginning to break it to standard form. I would probably leave the 3. I would probably do this step. So that would be the little bit of extra tax you have to pay if you want to go into standard form. But you can also see it's happy. You can see it's the same 3. Okay, Lademi, what is your question?
Sir, I didn't get any value for x, so I just wanted to know if I'm still on the right path.
Right.
Or
Okay. So did you do this way, the standard form, or did you do the turning point?
I did the standard form, and then
Okay.
I used the quadratic formula.
Okay, so you should have got minus 12, so 12 plus minus minus 12 squared, which is 144, minus 4 times 3 times 13 over 2 times 3. So I'm most interested in seeing what delta value you got.
Okay, x equals minus b, right?
Yeah, what did you get for delta? So you could be right. 4 times 3, yeah, it's going to be negative delta. Okay. So if there is a negative, what is the value inside the inside this thing here? Inside the square root?
Let me check.
I'll explain what it means. It probably means there's no x-intercepts.
Okay. Well, I got minus 12.
Okay, that's good. So what that means is there's no x-intercepts, because if delta is negative, there's no solution. So that's not a problem. That's correct. Now, what is my turning point going to be? Yeah, so and Paul, you're correct as well. So what's the turning point going to be? So I think the turning point is going to be minus 12. So it's 12 over 2 times 3. So it's 2. And that makes sense when I look at this, because minus 2 is 2. Okay, I'm cheating a little bit. I can see the turning point there. Yeah, 2, 1. Okay, I'm going to stop there for now, guys, because it's already 3 minutes past 7. But I think you can all see that to finish this, all you need to do is go through that process once again. All right. Lebo, if I could ask you to try and share a survey with the students. We've done a lot tonight, and I think it's important that we stop here and just let our brains consolidate. But I hope you enjoyed the lesson, and we covered a lot. So, if you need to rewatch the lesson, that's fine, because there was a lot in it, and especially students who were new. This was our 3rd lesson, so we had been building up to this for a while, and so do rewatch the stuff. Okay, cool. So Nisilia, I haven't drawn the graph, so I suppose I could draw it. Why? Okay, well, part of me is like, I'll just draw it for you. So here is, what was my axis of symmetry? X is 2. And my turning point was 2, 1. And the reason there's no x-intercepts is because this is a happy graph. So it never goes below the x-axis. We know that the intercept here was 13, and it never cuts the x-axis. So we just have the turning point, which is 2, 1. We have the y-intercept, and then we just label the function, which it was. So there are some parabolas that never cut the x-axis.